Hey guys, this is Raleigh Jones with routerbeast.com. This is our SD-WAN introduction, introduction to Cisco SD-WAN. And we'll take this in separate parts here. This first part is just an introduction of terms. So let's jump in. So when we talk about SD-WAN, the enterprise landscape is continuously evolving. It's continuously moving forward. There's constantly a greater demand for mobile and Internet of Things type device traffic. There's SaaS applications, cloud adoption. There's in addition to this, of course, there's security needs that are increasing and applications that are requiring, that are fighting for prioritization and optimization. And as this complexity grows, of course, there's a push to reduce cost and operating expenses. High availability and scale will always continue to be important. And so what happens is we have these legacy WAN architectures that are always under fire, so to speak, and they're facing major challenges under this evolving landscape. And so when we talk about some of these legacy WAN architectures, typically they consist of multiple MPLS transports or an MPLS paired with an internet or LTE type setup, used in an active backup fashion. Often this involves internet or software as a service traffic being backhauled to a central data center or regional hub for internet access. Now, this can create some different issues. Some of these issues will include, the inefficient band, or should I say insufficient bandwidth, along with high costs. There's application downtime, there's poor software as a service performance, there's complexity that's involved in the operations, there's complex workflows for cloud connectivity, long deployment times and policy changes, limited application visibility, and of course, difficulty in securing the network. So in recent years, software-defined networking solutions have evolved in order to address these challenges. SD-WAN is a part of a broader technology of what we refer to as SDN, software defined networking. Now, of course, software defined networking is a centralized approach to network management, which sort of takes away or abstracts away the underlying physical network infrastructure from its applications. So it separates those out. This decoupling of the data plane forwarding and the control plane allows us to centralize the intelligence of networks and allow for more network automation. Also simplifies operations, centralizes our provisioning and monitoring and our troubleshooting. So SD-WAN, it builds on these same principles of SDN and brings these to the WAN. So software-defined networking, of course, is a bigger and bigger and bigger thing as we need to automate. So why should we deploy SD-WAN? Why should we deploy SD-WAN? Well, the Cisco SD-WAN solution is an enterprise-grade WAN architecture overlay that enables digital and cloud transformation for enterprises. It fully integrates routing, security, and centralized policy and orchestration into large-scale networks. It is multi-tenant, it is cloud delivered, it is highly automated, secure, it is scalable, it's application aware, and it also involves rich analytics. The Cisco Viptela solution, which is the solution that Cisco bought out in 2017, this Cisco SD-WAN technology will addresses the problems and the challenges that we deal with in common WAN deployments. So when we talk about these problems and challenges, we just talked about some of those problems and challenges, but what are some of the specific benefits that we gain and we glean from going to SD-WAN? Well, some of these benefits include centralized management and policy management, okay, as well as operational simplicity. This results in reduced change control and deployment times. Okay, another benefit is a mixture a mix of MPLS and low-cost broadband or any combination of transports that can be used in an active fashion. This is going to optimize capacity and reduce bandwidth costs. Another benefit, of course, is the SD-WAN. Is built on a transport independent overlay system. It overlays across whatever type of infrastructure is there. So this overlay extends to the data center, branch, or cloud. Okay. There's also deployment flexibility. Now, due to the separation of the control plane and the data plane, controllers can be deployed on premises or in the cloud, or a combination of either. We're going to take a look at this in a moment, but Cisco vEdge router deployments can be either physical, or they can be virtual, or they can be deployed anywhere in your network. Okay, another benefit, of course, is the robust and comprehensive security that we can gain with SD-WAN. So this includes strong encryption, end-to-end network segmentation, router and security, or should I say router and controller security. Router and controller certificate identity. This involves what we call a zero trust security model. We'll take a look at that in a in our next segment. We're taking a look at terms in this segment. We'll look at the zero trust security model in another segment. So this this security also involves control plane protection, application firewalls. There's also a technology called Cisco Umbrella. Of course, we just talked about firewalls and other network services. All this comes along with this more robust and comprehensive security package within SD-WAN. Another major benefit is seamless connectivity to the public cloud and movement of the WAN edge to the branch. Okay. Another benefit, of course, application visibility and recognition, and application-aware policies with real-time service level agreement enforcement. And then last couple of items here: dynamic optimization of SaaS applications, those software as a service applications. These result in improved application performance for your users. And then finally, there's rich analytics, with visibility into applications and into your infrastructure. This enables faster troubleshooting, and will assist in sort of forecasting and analyzing your network for resource planning. Okay. All right. So these are some of our SD-WAN benefits. Now, as we talk about the SD-WAN solution, it's important that we understand these four specific terms that are part of the solution architecture. Okay, these terms are orchestration plane, management plane, control plane, data plane. Orchestration plane, management plane, control plane, data plane. Okay, so the Cisco SD-WAN solution is comprised of these separation of these different planes. Okay, so the orchestration plane assists in the automatic onboarding of the SD-WAN routers into the SD-WAN overlay. Okay, so we'll have these vManage, or should I say these vEdge routers, and that orchestration plane is going to be the onboarding aspect of this architecture. Okay, then there's the management plane. The management plane is going to be responsible for central configuration and monitoring. Okay, so we see that management plane right in here, and so the management plane is going to be where we do our configuration and monitoring. Of course, we've got the API, the REST API, and the those hooks into the existing software for the configuration purposes. Okay, then we've got the control plane. Okay, I'm sorry, and by the way, note that remember, the management plane can be multi-tenant, or this can be dedicated to specific tenants. The control plane, this is where we have our containers or our virtual machines. Okay, so this is going to build and maintain a network topology And this is where decisions will be made for where traffic flows here in the control plane. Okay, so once again, orchestration plane, management plane, control plane. Okay, and then finally there's the data plane, and the data plane, of course, is going to do, what we've come to know data planes to do, which is going to be, just like in looking at the control plane versus the data plane in a router. The data plane is going to be responsible for the actual forwarding of traffic, the forwarding of packets based upon different criteria that is configured and that's set in the control plane. Okay, so the data plane is actually doing the forwarding of those packets. The control plane determines, where the traffic should flow. Okay, so control plane, data plane, same concept as in traditional physical routing. And this should have had SD-WAN architecture. All right, it's a work in progress, guys. All right, all right. So those are your four components of, or the four aspects of the architecture: orchestration, management, control, and data plane. Okay. Next, we're going to take a look at these components themselves: the vManage, vSMART, vBond, and vEdge. If you notice, or if you look a little closer here, you'll notice that you've got vBond sort of involved in in that orchestration. Then you've got your management here, the vManage. Okay, vControl, or should I say vSMART, is involved with the control, and then vEdge is going to be your devices that are involved in your data plane. And so we'll take a look at each one of these. So vManage. vManage is your centralized network management system. Okay, that's going to provide us with a GUI interface to monitor, configure, and maintain all of our SD-WAN devices and links in the underlay and overlay network. So looking back once again, okay, we talk about vManage. This is where that resides, in that management plane. Okay, and keep in mind, vManage relates to the management plane. Next, we have vSMART, which relates, of course, to the control plane. All right. Okay, so the vSMART controller is, of course, software based. Okay, it's responsible for the centralized control plane of the SD-WAN network. Once again, software based. It's going to establish a secure connection to each of the vEdge routers and distributes the routes and policy information via the overlay management protocol, OMP. We'll be taking a look at that here in just a bit as well, looking at some of the specifics of OMP. As a matter of fact, we might take a look at that in the next. Yeah, we're going to look at more specifically. Well, yeah, a bit about that here in a bit. I'm going to take a look at that. Now I'm gonna save OMP for the next segment. So we'll be looking at that in the next segment. Okay. So anyway, OMP. Okay. So vSMART is going to establish that secure connection to each vEdge router and distribute routes and policy information via the overlay management protocol, OMP. Okay, acting as a route reflector. Okay, vSMART is also going to orchestrate the secure data plane connectivity between those vEdge routers by distributing crypto key information, allowing, and this of course allows for a very scalable architecture that does not have to rely on IKE. Okay, so next, after vSMART, once again looking at the architecture here, so we just dealt with vManage related to that. Related to the management plane. Then you've got vSMART, which relates to the control plane, okay, the vSMART controller. And then we have the vBond orchestrator. So the vBond orchestrator, once again, it is a software-based component that performs the initial authentication of those vEdge devices and orchestrates vSMART and vEdge connectivity. Okay, this is also going to be the place where we, this orchestrator, the vBond, is also going to have an important role in enabling the communication of devices that sit behind NAT. Okay, all of your devices that sit behind network address translation. Okay, so once again, looking at the topology here, that's where your vBond falls in right here. So vBond is the orchestration. vSMART, I'm sorry, vManage is your management plane. vSMART is control plane. And then finally, we're going to take a look at vEdge, which involves your data plane. Okay, so these can be hardware appliances or software-based routers. They can sit at the physical site or in the cloud, and they can provide, they will provide secure data plane connectivity among your different sites over one or more WAN transport. Remember, this is going to be WAN, protocol independent. It's going to be an overlay over an existing WAN infrastructure. Okay, so vEdge routers, referring to the SD-WAN solution, that is. Now, vEdge routers are responsible for traffic forwarding, security, encryption, quality of service, routing protocols such as BGP and OSPF and more. So it's just what it sounds like. It's a router. Okay, it's going to do traditional and typical routing services using the vEdge router. Okay, so so now, once again, quick summary. We've got the vBond right here, vBond orchestrator, the vManage, okay, the management software GUI that determines the management plane. Okay, and then you've got vSMART controller. Okay, this is where your configuration and determination of traffic decisions will be. Okay, of course, the management plane is where the configuration is. The controller, this is where decisions are being made as to how traffic will be forwarded and how traffic will be routed. And then, of course, the vEdge routers, this is where your data plane resides. Okay, routing between the data center and the campus and the branch and the home office, etc., etc. And so all of your typical routing functions that you think of happen here. Notice that all of this takes place as an overlay to whatever the layer 2 or layer 3 existing WAN infrastructure might be here. Okay, this is all of this SD-WAN architecture is going to be an overlay of whatever that secure control channel might be. Okay, whether internet, MPLS, or even 4G as is depicted here. Okay, so we've looked at those topics. Okay, vManage, vSMART, vBond, vEdge. Okay, now let's take a look at a sample SD-WAN topology. Now this topology depicts two sites and two public internet transports. Okay, notice that the SD-WAN controllers, okay, which are the two vSMART controllers. Okay, notice you've got you've got the two vSMART controllers and the vBond orchestrator along with the vManage GUI. All of these reside on the internet and they're reachable through either of these transports that we're talking about here. We've got the business internet transport, we've got the public internet transport. Okay, so either of these provides us with internet access and internet connectivity that gives us access to vSMART, vManage, and vBond, all in that SD-WAN cloud. Okay, so at each one of our sites, though, notice that we have vEdge routers. Now, these vEdge routers are used to directly connect to those available transports, the business internet or public internet. Okay. Now, a topic that we're going to be dealing with in the next presentation that I'll go ahead and introduce to you now as we talk about this is a topic called color. Color is used to identify an individual WAN transport. Okay, so different WAN transports are assigned different colors. Okay, so MPLS would be a color, or Private One, or Biz Internet, or Metro Ethernet, LTE. Each of those would be considered colors. Okay, those are referred to as colors. Okay, so this topology uses a color called Biz Internet, okay, for one of the internet transports, and it uses another color called public internet for the other. Okay, each of these once again referred to as colors in the SD-WAN terminology. Okay, so what happens is the vEdge routers form a data transport layer security or transport layer security control connection to vSMART. Okay, so these are, this is a DTLS or TLS, datagram transport layer security or transport layer security. And I'm gonna add those in here real, just so that you see the two terms that I just gave you there. DTLS or TLS. Okay, so the vEdge routers here, these vEdge routers are going to, they form the DTLS or TLS control connection to the vSMART, to these vSMART devices. Okay, and they connect to both the vSMART controllers over, to both of these vSMART controllers over each of these transports. Okay, so the vEdge routers securely connect to other vEdge routers using IPsec tunnels at at the other sites over each of these transports. So ultimately, the communication that takes place between the vEdge routers is taking place using IPsec tunnels. Okay. So now there's another aspect I'll just sort of jot in here, and that is bidirectional forwarding detection. Okay, so this is a protocol that's enabled by default and will run over each of these tunnels that I just indicated. Now this bidirectional forwarding detection, we use it a lot with OSPF. Once again, it's enabled by default in this setup, and it will run over each of the tunnels, those IPsec tunnels, detecting loss, latency, jitter, and path failures. Okay, so in this topology, where we see each of the different components: vSMART, okay, the controller; vManage for the management plane; vBond for the orchestration plane; vEdge for the data plane, utilizing, and let me throw in a couple of other terms here that I mentioned, uh, utilizing these colors. Okay, Biz Internet and Public Internet; those are colors. Also, we mentioned OMP. Okay, that we mentioned that actually on a previous slide, but I just figured I'd go ahead and just throw it in here as we talked about that. Remember, that's what vSMART is using for the overlay management protocol. So overlay management protocol, colors, DTLS, and TLS. Okay, those actually could sort of be put in together, side by side. And then finally, there's bidirectional forwarding, which is used to run over those tunnels to detect loss, latency, jitter, and path failures. Okay, so these are some of your components that are involved in this sample SD-WAN topology. We've talked about colors, OMP, DTLS, TLS, bidirectional forwarding. Okay, some of the other terms we talked about was the orchestration plane, management plane, control plane, and data plane. These are all important for you to recognize in terms of understanding SD-WAN. But even more important to that would be being able to match. And I'm going to just do this as a fun little thing to do here. I'm gonna pause this. So yeah, I just moved these guys over. And so in looking at this, you can sort of look at this like a matching type thing. You want to match up what you've got on one side to what you've got on the other there, of course. The vManage would be management plane, vSMART would be control plane, vBond goes up to the orchestration plane, vEdge goes down to the data plane. And so you could sort of do, you look at this as a matching deal. And what I can do is I'm going to do is I'm going to just sort of move them around. All right, vBond is that orchestration management, vSmart is control, and vEdge is data plane. Okay, and so that's a summary of some of those SD-WAN terms and concepts. That gives us a quick summary of that. In our next discussion, we're going to dig deeper into the concepts of color, overlay management protocol. We're going to talk about VPNs, those VPNs and how those are set up. We're going to also talk about stuff like T-lock extensions and just dig into SD-WAN and the actual operation and the way the traffic flows, the way things work together, the way these devices work together. We're going to look at that in more detail as we go forward. So once again, thank you very much. Thank you very much for taking a look with me. This was a brief look at SD-WAN, Cisco's SD-WAN. And I'm Raleigh Jones with routerbeast.com. See you guys next time.